Hello doctors, let's get to see the sources that contributes to adenosine triphosphate production and how does that adenosine triphosphate breakdown hydrolysis leads to energy liberation, and using that energy how muscle contracts and what are all the other purposes where muscle relies on the energy derived from ATP hydrolysis, all these things. So in nutshell, it's going to be muscle energetics and muscle metabolism. Alright. So people, before we again get into the content, let's understand one thing at the outset. The energy that we are going to speak about is a chemical energy, right? So the power, the energy that is going to be liberated when a bond between adenosine and phosphate is getting hydrolyzed. Now at the outset, let's get to see where are these energy getting utilized. Alright, so let's start with energy utilization. In a muscle, what are all the purposes we use the energy for? Number one, you guys know you require ATP and you require ATP hydrolysis for number one, sliding of thick filament and thin filament. In another word, cross bridge formation. Cross bridge formation between thick filament, which is nothing but myosin, and thin filament, which is nothing but actin, guys. So the cross bridge is formed between heads of myosin and body of actin. That's the first purpose and target where we are going to devote energy to. You require ATP hydrolysis for this step to happen. Number two, it is going to be running sodium potassium ATPase. And you know very well the importance of sodium potassium ATPase. You have studied this in general physiology as well. Sodium potassium ATPase function is crucial for two purposes. Number one, to maintain ionic equilibrium. Ionic equilibrium, which means sodium must be deposited in extracellular fluid, potassium must be deposited in intracellular fluid. During depolarization, the composition is going to be changed. You are going to have plenty of sodium influx into the muscle cell cytoplasm, and that is exactly what is going to cause depolarization. So in the process of repolarization, potassium starts effluxing out of the cell. Now you require sodium potassium ATPase to take sodium back to extracellular fluid, potassium back to intracellular fluid, which is getting done by sodium potassium ATPase people, and this process is what is called as maintenance of ionic equilibrium. And the second important function of sodium potassium ATPase is to maintain cell volume. And again, you know the basics. We discussed this in osmosis as well. Every time when an ion, be it a cation or anion, it doesn't matter, every time a charged molecule, a charged atom is kept in a water medium, this charged atom is going to attract water, and this is going to make the size of atom so huge that that atom is going to be imbibed with water. So people, if I say sodium enters a cell to cause depolarization, it just not mean sodium crystal alone. It also means sodium moving along with water. So if you observe the depolarization which brings plenty of sodium inside the cell, this practically makes the cell to become enormously swollen to the point of rupture. So you got to keep the water out of the cell so that the cell volume remains intact, for which you require sodium potassium ATPase. And for sodium potassium ATPase to operate, you need ATP hydrolysis.